So, hello again. I've taken a hat off and I've taken another hat on. You get to see me again. I'm now wearing my work hat, my actual work hat, instead of my volunteer hat. The talk I'm going to give you today is called Automation for Brownfield Networks, Designs and Experiences. And this is a talk that could have been hours long. Fortunately for you, I only have half an hour. So I will touch upon some things and some experiences and design, things like that, but I won't be going as deep as this talk could go, but hopefully I can come back another time and continue where we left off. Which way do I point this? There. Yeah, good. So, I'm Alan Ising. I've said that a couple of times now. I work as a network automation architect at Telia Company. I'm based in Oslo these days. I have been for the last almost 5 years. I've worked in various business-to-business kind of service provider companies for the last 15 or so years. And I've spent about the same amount of years wishing we had better provisioning. When I started in this industry, when I had my very first job while I was still studying, I worked at a small residential ISP. Well, it wasn't that small. It was a residential ISP that had a great piece of software with a big button that said provision. And once you clicked that button, things magically worked. Then I got my first real job at a sort of business-to-business kind of service provider. Not a provider that exists anymore. But there, when we provisioned the customer, we opened an SSH connection to a switch, then we typed some commands in, then we opened another SSH connection to another switch, and so on and so forth. And I just wished that that provision button was there. It's not working very well, this. Where do I need? There we go. I'm going to use the terms greenfield and brownfield in this presentation. If you haven't heard of those terms, it's greenfield deployment is basically when you deploy to as a completely new network, completely new automation. There's nothing in there before. You're not bound by any legacy or anything like that. But brownfield is when you try to integrate with something that's been running for a long time. In this case, we had an active network that's been running for a long time. We also had an active provisioning and automation platform that we had to replace. It's not working very well, this. It's going to be a long talk if I have to wave like this. So the network automation I'm going to talk about today is based on a project I've been part of for the last couple of years. 2 to 3 years I've been working with this project. I'm not going to talk about the project itself. It's just the basis of the foundation of my experiences here. But I'm going to focus on some of the architectural choice, the approach we had with automation. We based our automation on Cisco NSO. I'm not going to talk specific Cisco NSO solutions today. I'm going to try to keep this very generic. Cisco is not paying me any money to advertise their product, so I'm not going to do that. Good. It's business-to-business services. If you're not familiar with those kind of services, it's layer 3 VPN services, internet transit services, layer 2 solutions, etc. And these are very challenging to automate because they're usually a lot more complex than residential services. This is usually because there's a high degree of bespoke, or what started off as being bespoke, and has become now a myriad of add-on, value-added services, etc. And these are even more complex given that many of these networks are large and old, have various parts of the network with legacy technology that also needs to work with all these various add-on products. So that makes it extremely complicated to properly model these things and automate them. The biggest challenge there is definitely documentation, reconciliation of documentation with reality. So you must import your services into your new automation, and that must not only just be correct documentation, but the output must also match whatever you had in the network there, which might not match completely with your documentation. If this doesn't match, you have to do manual intervention and that's an expensive process, takes a long time, and you want to avoid that. Let's just quickly walk through the overall architecture that we want to build in order to make a scalable automation framework here. This is sort of an idealized architecture. Less can and will often do. That said, there are some principles here that we want to stick to. On the top of the picture, we have the OSS stack. There's stacks and stacks on top of that, for example, sales and BSS. But in terms of this, this architecture will start at the top with the OSS layer. Here we have two components that are interesting to us. We have the SOM component and the ROM component. So this is the Service Order Manager and the Resource Order Manager. Our network automation here, I've called a domain orchestrator. I'm going to use a lot of different names for this stuff. But the domain orchestrator is meant to indicate that you can have multiple automation systems depending on what kind of network you're working with. If you have, for example, I was working with the IP MPLS domain, so that would be one orchestration platform. You could also have another one for SD-WAN, for example. It's up to your service manager to direct the requests to the right domain orchestrator in order to produce the correct kind of services. Then we have various activators which are done for scaling purposes as well. So if you have a very large network, you want to have multiple nodes communicating. Maybe you want to have one for your CPs, and maybe you want to have one for your core backbone network. The resource orchestrator is responsible for handling everything that has to do with resources. So that's usually inventory-related operations, getting IP addresses out of a system, or allocating VLANs, or creating or removing devices from the network. And we want to have this architecture so we can separate concerns between services and resources and achieve what we will call for the intent-based orchestration, which is a bit of a buzzword, I do acknowledge that. But in this case, it means that we want to keep the realization away from the service configuration. It's sort of to say we want to split the what from the how. So let's try to sort of understand what we mean by this by going very much in a simple example here. Let's say we have, well, this is barely visible on screen, but imagine there's some Cisco config up there. So imagine we were going to configure an internet service. We have a simple configuration here, interface gigabit Ethernet 01, IPv6 address, something. Usually when you do this, you want to use a template because that's what every piece of automation software does. It uses some sort of template somewhere in the system, whether it's like Ginger style like I have here, or it's some XML stuff like Cisco NSO does, doesn't matter. You usually want to do that, and you assign variables like interface, IP, and prefix wherever it makes sense in your system. Then you would have some sort of activator or some sort of automation software that has the prime responsibility of assigning values to those variables, and that's fairly simple at this point. But then you can create a public API with that, and suddenly got something that looks like that. So you have a service ID, and you have those parameters that correspond with your template. But the challenges here is that you're now mixing resource and service parameters together. So let's say you store this as your service information, but next week you decide to decommission this router that has this service, and you then have to rewrite the service. Is it the same service if you change these parameters, or do you have to modify it every time? What we can actually say, it's the same service intent. So we usually say that the northbound system, it communicates intent to us, and it pushes the intent to the activator or domain orchestrator or whatever we want to call it. So in this case, then we have instead a state of the configuration that we manage on the southbound side of this. So on the top side of it, we can say our state is I want an internet service with IPv6. We push that into the activator, and the activator interprets this as I need to push an IPv6 address, so and so, on this and this interface. In this very simplistic example we're working with here, we are just actually reduced to just a service type, an address family, and something we call an endpoint here, which is a point of reference to where we want this service to be present. Our activator then interprets this and says, okay, I need an IPv6 address in order to fulfill the service intent. So let me ask my resource manager, my inventory system basically, please give me an IPv6 address, and it will give that back. And now we have everything we need to provision the service. And this is really sort of the core concept we need to take in order to scale this up. We're storing the, let me see. Yeah, we're storing this blob here. This is actually our service configuration. This is a service graph, and this is the only information we need to store in order to produce the service. Then we can move it around and change the definition of this endpoint 100 to something else, and we can produce it somewhere else in the network. It might look different, but it still fulfills the original service intent. So this was our goal, to do this on a large scale for business services. So we scaled that up, this thought up to layer 3 VPNs, internet transit services, business internet, layer 2 VPN point-to-point, etc. And I've sort of included a simplified version of that on the right here. And the challenge here is this works for new services. Of course, we can program our service to do the right thing for new services, but for old services, there might have been made some decisions in the past that doesn't actually match what we would do today. So we had to break the model a little bit, put a lot of linknet or take a different route through the network. But the challenge is really here, and it's really dependent on mapping the resources correctly in the network. So let's put the first undeniable truth out for the day. It cannot be understated how impossibly hard it is to perform clean data migration. So, just for some context, how many in this room would be able to recreate their network service for service just from the documentation? Rancid doesn't count. No hands? Thought so. But nevertheless, this is what we need to be able to do in order to have the automation at this level. And there's really no way around it other than just cleaning up documentation until you're done. And it's going to be super meaningless work in many ways. And the worst part of it, it's work that you need experts to do, experts that are usually very busy with things that actually is meaningful. Instead, they have to spend time cleaning up Excel spreadsheets and writing parsers for the network to figure out which router ID you used in the network and things like that. But the thing is, when you start this work, you need to pick an approach. Let's see, I'm ahead of myself here. You need to make a choice, basically. Do you want to automate in the way where you reproduce what's in the network? Or do you go for an approach where you create a new configuration standard, something that's simpler to automate, one common standard to sort of rule them all style? And it might be extremely tempting to go for this functional equivalence road, just saying, it's too inconsistent in our network, we can't automate this, let's just make something new. However, I would actually advise some caution there. Because when you go for the exact output, and we did that, you can measure your success rate. You can start producing your services, and you can figure out how well your automation works. And we did this by loading all our services into a clean environment, then just using the dry run functionality in NSO. I know other automation software systems have that functionality as well. You basically just apply your configuration. You get a list of changes that this has caused, and you analyze that. So we basically wrote some software that went through these and categorized them into 3 kinds of categories: in sync, safe changes, and unsafe changes. In sync, of course, means whatever is in the network is exactly like we produced it from automation. That consists of circa 0% of our services. And that's because safe changes are also things like we rewrote the description field slightly, or we just aligned the service to how it was supposed to look. Like there is some configuration statement missing in the network, but our automation pushed it, so now we are doing a change to the service, but it's fine, really. It doesn't change anything, it doesn't break the customer, it doesn't change what we are delivering to the customer. Unsafe changes, on the other hand, is everything we really need to look at. And this could be due to our documentation being wrong, for example. We find a 100 megabit service in the network, but it's only a 10 megabit according to our documentation. Who's right? It's probably the 100 megabit, and we just forgot to update the documentation. Lots of things like incorrect IP addresses and VLAN mismatches indicate more that our documentation is wrong, we are loading the wrong service into the wrong port, things like that. But it also shows what kind of bugs we have in our system. So once we have a high enough percentage of safe changes, we can go live. But once we've gone live, we can start to look at these functional equivalences. We can start looking at what can we change in the way we produce output to make it more automation friendly, to make it more readable or consistent or correct. But once we do this, we cannot do the dry runs anymore. We cannot get the statistics going anymore. We will just get a lot of false negatives, and we can't use it as a KPI. Things that could be automation friendly or human friendly are sort of a little bit fluffy to define, but things like apply groups is a clear example of something that's definitely human friendly, but not automation friendly. That's a number of reasons for that. It could be that it's hard to apply and unapply these apply groups. You don't know what they contain. So there's part of the network configuration that you're pushing out that contains stuff that you don't have control over. It could also be a lot of free text comments. There's usually a lot of that in route maps and things like that. That's not very automation friendly either. Generally, we want to have our service configuration as self-contained as possible. And that's because we don't want to stand in weird ownership situation where multiple services own critical parts of each other's configuration. It's sometimes not avoidable. Things like VRFs is a good example of shared configuration that you need to be really careful about. You need to make sure that you don't accidentally remove the whole VRF definition in your router just because you only know of one service that is using it. Maybe there are more services on the box that was manually provisioned, and then you've created an outage for the customer. So try to make configuration as self-contained as possible. One of the things we spend a frustrating amount of time on is various differences between Cisco platforms. Some of these differences are extremely trivial, but really, really annoying to deal with. It could be, for example, I have an excerpt here of various flow control supports and various Cisco switches. They can be either supported, unsupported, or supported with a default behavior. So if it's unsupported, the command doesn't work, it causes an error, your service provisioning will fail. If it's supported but with a default value, it means that you can push that command, I don't know how many times to the device, it will never show up in the config. And that's also frustrating for automation, especially if you want to see if your service is in sync or not. And then you have like platforms where it's different behavior depending on what speed the interface is on. So this led us to develop an extremely annoying system where we have to flag every non-standard behavior on every interface there is on our switches. There's no way around it, it's just how it is. So once you've reached a good enough quality in your tests before going live, you can actually go live, but you have to be prepared to support your organization a lot. We planned a month of hypercare, as we called it, meaning we had a month dedicated to just having daily bug stand-ups. I sat next to the delivery engineers and I held their hand while they configured services. And it was fine, but we really saw that the need for extra support lasts on for up to half a year. And then it's regular support from there. And the problem with supporting network automation is that a lot of the people who write network automation may not have the biggest service delivery network engineering experience. And there's no burn or anything here. They're excellent programmers, and that's their specialty. But that means that if a user comes up to them and explains what they're trying to do, it might actually be very hard to help them. So you need to have a couple of super users trained from the local organization to just be super users in the system before you can let them loose. And yeah, I could go on forever in this talk here, but most of it will be war stories, and those are best had over a cold beer. So let's take some questions instead, if there are any.
My name is Henrik Kramselund. I'm from KEA and security. Did you meet up with some configurations that were just too complex, so you went back to the customer and actually reconfigured some stuff? Or
we tried. We have some examples of things that we're still working on this day that hasn't been delivered completely yet, because the complexity is just extremely high. But for various reasons, we haven't simplified it a lot. We have sort of taken a couple of variants where they are functionally the same, but there's some technical reason for choosing the other over the first one. That has to do with, like, okay, maybe it takes a little bit more resources in the router to do it this way. So, and then we've sort of aligned those configurations. We really want to be able to measure still how well we're in sync with what's in the network. So we want to avoid as many of these optimizations as we can still.
Hello, my name is Benjamin, New Day. Alan, what do you do with build to orders and stuff like that? Is that a manual thing, or is that something you build into the automation and then let that build it? We've been lucky enough to have most of the build to order stuff going on in the CPEs and away from the PE configuration. And the CPEs are a lot more free to have customization there. But we generally try to model our services rather flexible, so you can put in extra net, you can put in an extra routing, and if you need some specific functionality, well, you put it on the CP.
My name is Morten. I'm from SmartShare Systems. You mentioned that when you were testing this, you often encountered interfaces with the wrong configuration of bandwidth, for instance. Did you use this as a tool to improve logging and traceability, so you were better able to see why is this interface configured for 10 megabits instead of 100 megabits or something like that?
It's hard to do why in a project of the scale that we had to do it on. So it was more of us being able to say the documentation must be wrong here. Why it is one thing and not the other is too hard to tell, unfortunately.
I'm not asking about correcting the documentation or the configuration. I'm asking about when you use this tool to provision something, did you add some logging or traceability so you can go back in the logs and say, why is this configured like that?
Yeah, there is definitely auditing functionalities and audit trails in them. I'm not super happy with the functionality we have currently. I want to improve it at some point, but at least for a short time frame, you can go back and see who configured what and type which commands and things like that. So you get some auditing. I'm not super happy where it is right now. I would like to have more visibility of things like that, especially for historic contexts.
Exactly. Thanks.
Hi, my name is Kali from Global Connect. I feel like this presentation spoke to me personally. Did you ever go back and think maybe you should redo some of your documentation? Did you change your documentation to better match how you would like to automate stuff in the future? I feel this is like a bigger problem, especially for my company.
Yeah, I feel you. Documentation is the nightmare of this industry in many ways, and I guess there's really no way around it. You just have to have good systems that do this for you in some ways. I don't think we necessarily improved that much from this project in terms of pure documentation. I'm a little afraid we'll be in the same situation in 5 years, unfortunately.
Hello, Mikkel Troos from NetNordic. A point about documentation. When you do systems like that, like this, sort of the service documentation is implicitly hidden away in the BSS or OSS system, so you can always trace which parameters got in from which service ordering. So in that sense, you sort of have documentation already in place. As for what is actually configured in the devices, when you do like Alan and pull things out of a resource manager pool or something, you can always see in your resource manager which service request pulled those resources and where they're supposed to be applied. So it actually do solve some documentation issues, I would think, going forward. But of course, not in a annoying brownfield situation, it won't.
No, I don't want to say too much about this because it's kind of complicated, but you need to make sure that you're tracking the right things in your BSS and OSS layer in order to get the documentation level you want. And that has to do with how you model your services in the OSS layer, whether you're actually capturing the right fields or you're just pushing technical attributes back to the user and letting them fill out stuff, and then it's just gone again. You need to be really careful how you design your OSS systems. I'm not an expert on OSS systems, but we spend a lot of project time trying to model products in the OSS layer, and it's complicated.
Tom from Cloudflare. Did you, at any given point, considered synchronizing upwards from what you have as configuration and then installing that in whatever other sources of truth that you're using? And if you did consider it, did you go with it or not? Or?
In the end, it was a combination of everything. We did read a lot from the network just to, I mean, we started in both ends and saw what was in the middle when we were done with it.
Hello? Yeah. Well, I forgot to introduce me last time. I'm your chair for this morning. I'm Mikkel, in the DK program committee. So if you want to bitch about the program, that's me, that's Alan, that's Fergus. Please give a big hand to Alan for his presentation.
Thanks, man.